Welcome back, everybody, to another Swift programming tutorial. This is part 13 of our basic series, and in this tutorial we're going to go over classes. Classes are a part of object-oriented programming, so before we get started, let's go over some information regarding object-oriented programming and classes. OOP, or Object-Oriented Programming, is a programming model based on the concept of objects, where collections of objects or categories of things are used with classes. Classes typically consist of functions, which are also called methods within a class, and data, which are also called properties or variables. And typically these functions and properties have characteristics in common. Methods provide functionality, and properties typically store or compute values. The classes are then used throughout the program in a variety of ways, including the ability to create new objects, change objects, allow objects to interact and perform tasks, modify data, and other functionality. Classes can help you organize and reuse code efficiently. Classes also often include initializers and conform to protocols. Initializers help to set up the initial state for the class, and protocols help provide standard functionality. Okay, so let's go ahead and get started with our first example. To create a class, you use this syntax here. Type out the reserved or keyword class, and then give your class a name. Then you use your curly brackets, and you put your class code inside the curly brackets. So in our next example, we want to create a simple class that includes a variable and a method, and the purpose of this class will be to help us to keep track of spare change. So let's say that we have a $1.25 right now in spare change. Let's create a variable to hold that amount. Next, let's create a method that will allow us to continue to add to our spare change. Let's call this method add_to_spare_change. It's going to take one argument, which is the amount of spare change, and it's going to be of type double. We don't need this method to return anything, we just need it to perform a task. So we don't need to do any type of return like that. Let's access our spare change variable. Let's use a plus equals to create a running total for the total amount of spare change. So the function will take the amount argument, and then each time we call the function and add an amount, here it will be added to this variable spare change. Now let's go ahead and create an instance of class 2, which you could also call your object. But before we do that, let's give this class a better name, because class 2 is not very descriptive. Let's call this spare change. Okay, so to create an instance, let's go ahead and create a variable first. We'll call this current spare change. Then we're going to type out the name of the class that we want to create an instance from, which is spare change, and then after that we'll just put an empty set of round brackets. Okay, so here we have created our instance, and now we can use that instance. And the first thing we want to do is access the class and get the current amount of spare change. So let's use a print to display. Let's access the spare change. Go ahead and run this. And you can see down here in the console we get $1.25, which is the current amount here. Now let's say that we want to add some more spare change. So to do that, let's go ahead and access our instance again. But this time let's access the method add_to_spare_change, and let's say that we want to add 75 cents. So let's put in 0.75, and now let's go ahead and display the current spare change. And since we used our method to add to the spare change, before we had $1.25 and we added 75 cents, now we should have $2. Okay, so you can see down here in the console, now we have $2. Now this is not formatted as a currency, and there is a way to do that, and we'll get into that in future tutorials. Before we move on, you could also use this same method here to subtract. You would probably just want to give it a better, more descriptive name instead of just add to. And to subtract spare change, you could just put a negative sign in front of this 75 cents. So let's go ahead and run this and see what we get. So before we had $1.25, Then we subtracted 75 cents, which leaves us with 50 cents. Now, another thing we could have done with this class is to create spare change accounts for several people. And when we create the instances for that class or the objects, each instance or object could be a new person. However, to do that, we would not want to use this setup. And a possible way that we could have done that is to use an init. So now let's go ahead and show you an example of how you can use an init. So let's create our class and call it employee class. Now, just as we mentioned above with our spare change example, if we wanted separate people to have their own spare change accounts, we probably wouldn't want to use the spare change class the way we created it, because we would want each person or each instance or object of that class to be unique. Now here in this class, the employee class, we're going to go over how you can create unique objects or instances to allow each employee to have their own unique profiles of data and information. So for this employee class, the two things we want to include are their names and their pay. So the first thing we want to do is go ahead and create some variables. Then we want to go ahead and create our init. And now we have created our init. So when we go ahead and create an instance of this class, it will automatically ask for the name and the pay, and that information will be unique to that instance or object, which will be each unique employee. Now, before we create our instance, let's point out one thing. This is not a typical way to create an init. However, it can be useful to help you get used to how the init works with the variables. So notice that this name and pay within the init curly brackets correspond to these variables, okay? And then this full name and this salary correspond to what goes inside the init round brackets. And you'll see here in just a little bit why that's good to know. So let's go ahead and create an instance, and let's just call this E1, short for employee 1. Let's access our employee class. And now we're going to use our init. You can see that the pop-up automatically shows you that we need to put in the full name and the salary. So let's put in the full name, Steve Smith, and let's say the salary is $75,000. Okay, so we have created our first instance or object, and this is a starter profile for the employee Steve Smith. Now we could go ahead and create another employee called E2. Again, we just put in the full name. We'll say this is Sally Smith, and we'll say her salary is also $75,000. Okay, so we have created two instances of the employee class, each one unique to an employee, one for Steve Smith and one for Sally Smith. Now let's go ahead and delete that, and let's move on to our next example. Now, as we mentioned, the way we created our init here is not the typical way to do it. So now let's go over the more common way. Let's go ahead and create our class. Let's just call it employee. Let's create three variables that will apply to each employee, which will be their full name, email, and salary. Okay, so we created our three variables, full name, email, and salary. Then we created our init here. So each time we create an instance of the employee class, it's going to ask us to fill in the information for the full name, the email, and the salary. Now, here's the part that we were talking about, and this is the more common way to set up your init. You want to go ahead and use self, use a dot and access your variable name, and then assign that same variable name. Let's do that for the rest. Now notice up here we pointed out which names apply to the variable names versus the init. So as you can see, the name and the pay applied to the variables. And what comes after the assignment applies to what goes in the init round brackets. Now the same thing applies down here in this example. And that can become just a little bit more important to know about because you're using the same variable names, and the only thing that's differentiating them is the self. Okay, so for example, this full name, email, and salary applies to what's in the init, and then the self, full name, self email, self salary, those apply to these variables here. So you might be asking, what is self? Now here's a little information about self. Self represents the instance or object itself. Okay, so you can think of self as the instance or object you will create when you use your class. So for example, if you had self.fullname equals full name, that would be somewhat equivalent to employee.fullname equals full name, or the actual full name, Bob Smith, okay? Now the important thing to pay attention to is this employee 1, which you'll see here in just a little bit, will be the name of our instance, okay? So employee 1 dot full name here is the same thing as saying self dot full name. So the self is equivalent to the instance, okay? So that's just one way to think about it. Now, before we use our employee class, let's go ahead and add a method. And we want this method to apply a raise to each employee. Okay, so when we create our instances from this employee class and we start filling in the information for each employee, this function should allow us to apply a raise to that person's salary. So now let's go ahead and create 3 instances for 3 unique employees, and their names will be Bob Smith, Alice Nelson, and Pat Mahoney. Okay, so now we have created 3 objects or instances of the employee class, and each one is a profile for each unique employee. And now we can use these objects in all kinds of different ways. So let's show you a couple examples of that. So the first thing we want to do is access the employee 1 instance and its information. So let's go ahead and put this in a print to display. Let's call up employee 1, and we can use a dot to access its properties and methods. So the first thing we want to do is access the full name. Next, let's go ahead and access the email. And finally, let's access the salary. Let's go ahead and run this. So you can see down here in the console, we have accessed all the information for the employee 1 object. Name, Bob Smith, the email, and the salary. Next, let's say that it's time to give Bob his raise. So to do that, we can access employee 1 object, use a dot to access the apply raise method. And now that raise should have been applied to Bob's $50,000 salary. So let's go ahead and access his name one more time, full name, and let's access his salary to make sure that it has changed. Okay, so you can see before, here, his salary was $50,000. Then we went ahead and applied the 4% raise, and now his salary is $52,000. Another thing we could do with all of these objects is we could go ahead and put those inside of an array and then access the information from those objects in different ways. So let's go ahead and create an array. We'll just call it employees, and let's put in employee 1, 2, and 3. Let's go ahead and access employee 1. So we'll use our array variable name. Then let's use our subscript syntax to access the first employee in the array. And let's just go ahead and see what the name is for the first employee in that array. Okay, notice the syntax. We use the subscript syntax, and then we use the dot, and we access the full name. So as you remember, array indexes start at 0. So this 0 should be employee 1, and the full name of employee 1 is Bob Smith. Let's go ahead and run it. And you can see we get Bob Smith. Let's comment out those prints so we don't get confused down here in the console. Run it again. Now another thing you could do is iterate over that array. Let's use a for in loop. And let's use this loop to go ahead and print out all the information for all the employees. Okay, so you can see down here, we get all the information for employee 1, 2, and 3. Now, another one of the big benefits of using classes is the ability to subclass. So let's show you an example of that. So let's say that we want to create a manager class, but we want to use some of the information that we created in our employee class. So we want to use some of what we have created here for our manager class, and to do that, we can just type out class. Let's name our manager class manager. You just use a colon and type out the class name. Let's put in our curly brackets. So this manager class is a subclass of this employee class. Some other terminology you might hear is that employee is the parent class of the manager class, or employee is the superclass of the manager subclass. And what this will do is it will allow the manager subclass to use the properties and methods from the employee class. So let's go ahead and start building our manager class. Now, one of the things that makes a manager different from an employee is that they have team members that they're responsible for. So let's go ahead and create an empty array to hold those employees. Now, as we mentioned, we're going to go ahead and reuse some of the information from our employee class. So when we create our init, we want to make sure that we can still use the variables from that class, including the full name, the email, and the salary. So to do that, let's create our init. And now let's put in the new variable that applies only to the manager, which is team members. Okay, so just remember, these three variables, full name, email, and salary, were also here in our employee class. So when we subclass, we can still use those, and we just put them in our init like this. And then when we use a new variable, such as team members, you should be able to just go ahead and put that after the variables that are in common to both classes. Okay, now for the new variable team members, we want to go ahead and set that up like we set up the other variables in the employee class. So we'll type out self.teammembers equals team members. And to allow for proper subclassing of the variables that the manager class and the employee class have in common, which are the full name, email, and salary, we want to do what's called a super init. So let's type out super init, and after the colon for each one, we can just go ahead and put in the same name as the descriptor. So for full name, we'll put in full name, email, we'll put in email, and so on. Now, just like we have done for our super init with the variables, we want to do something similar for our function from the employee class, which will allow us to use it, but just change it ever so slightly. So to do that, let's use an override. We're going to type the function out pretty much the same as it was in the employee class, and then we're going to make one small change. So instead of a 4% raise, we're going to put in a 10% raise. Okay, so now we have created our manager subclass, which will allow us to use all of the functionality and properties from the employee class, and we've made some minor changes. So now let's go ahead and create our manager objects and show you the differences. Our first instance of the manager class will be manager1. Let's use the manager class name, and let's fill in all the information. So our first manager's name is Albert Gold. His email is golden@email.com. Let's put in a salary of $89,000. And let's put in his team members. So his team members include Sally, Janet, Tom, and Scotty. Now, just like before, we can go ahead and access the object, manager1, and its information. So in this case, let's just go ahead and access the full name and the salary. Let's go ahead and run it. Okay, so we get Albert Gold and his salary, $89,000. Let's go ahead and apply the raise for Albert. Now notice before in the employee class the raise was 4%, but we did a slight override and we changed the raise percent to 10%. Let's go ahead and run it. Okay, so before the salary was $89,000, we went ahead and applied the 10% raise, And now Albert Gold's salary is $97,900. Let's go ahead and see if we can access Albert's team members. And you can see down here in the console, we get all of Albert's team members. So that's all we have for this tutorial on the basics of Swift classes. We've tried to provide a pretty good foundation here for classes. However, note that we have really only gone over the basics because you can do a whole bunch more with classes. And we're going to get into a lot more of those cool things that you can do with classes in future tutorials. So join us for those, and we'll see you next time.